Okay, class, in this lesson, we are going to learn to use the techniques of finding the zeros of polynomial functions to solve specific problems. So let's go ahead and get started with the first example. So here we are going to use zeros to graph a polynomial function. So we're going to be doing some graphing. And the first thing you want to do is find the zeros of this function. F of x is equal to x times x minus 4 times x plus 3. Okay, so the zeros of this function will be x equals 0, x equals 4, and x equals negative 3. And how did we get that? Okay, so we have three entities, x, this x minus 4, and x plus 3. And in order for this function to equal 0, one of these three has to equal 0. So when x is equal to 0, then this entire function is 0. And that's why one of our options is x is equal to 0. Another option is if this quantity here, x minus 4, is equal to 0, and solving for x, we see that x would be 4. 4 minus 4 gives us 0, and so 0 times whatever value these are will make this function 0. And then lastly, x plus 3, if we make this equal to 0, then this entire function will be 0. And so we see that negative 3 plus 3 gives us 0. So hence we have x is equal to negative 3 here. So if this is 0, then this entire function is equal to 0. Okay, so here we have a chart, okay, indicating the intervals from negative 3, so x is less than negative 3, x is between negative 3 and 0, x is between 0 and 4, and x is greater than 4. Okay, so how did we get those values? Well, that came from these x's that we solved. Okay, so we said x is equal to 0, it's equal to 4, and equal to negative 3. So what this tells us is that whatever the function looks like, we know that the graph will intersect the x-axis at these points. So let's go ahead and plot those points. At negative 3, it'll cross the x-axis. Okay, how did I get that? X is equal to negative 3. Okay. And then the next one is at 0. So we're going to go ahead and plot a point at 0 where x is equal to 0. And lastly, we're going to plot a point at x equals 4. So that is right here. Okay. So then these intervals that we have written here will be from negative infinity to negative 3. And then this interval will be from negative 3 to 0. This interval is from 0 to 4, and then this interval would be greater than 4. Okay, so now what we wanted to determine is what is the value of an x in each of these intervals. So for example, let's go ahead and pick an x value of, say, negative 10. So that's right about here. Okay, x is negative 10. So when x is negative 10, okay, this value is going to be negative, right? Because negative 10 is negative. So we're going to give this a negative sign right here. Okay, and then when we plug in negative 10 for x here, negative 10 minus 4 is negative 14. That is still a negative number. So we're going to put a negative sign here. And then when we substitute this x for negative 10 plus 3 is negative 7. Negative 7 is a negative number. So we're going to put a negative sign here. Okay. So now we look at these three signs and we see that a negative times a negative gives us a positive, but then a positive times a negative gives us a negative. And so my product here is going to be a negative. Okay, so that's going to be negative. And now let's take a look at the next interval. from -3 to 0. So that is in this space here. So let's go ahead and pick x as -1. Well, when x is -1, it's a negative number. So we're going to go ahead and put a negative sign there. When x is -1 here, -1 minus 4 gives me -5. And -5 is a negative number. So this gives us a negative sign. And then -1 plus 3 is 2. It's a positive number, and so we're going to put a positive sign there. Okay, so then a negative times a negative is a positive, and then a positive times a positive gives us a product of a positive. So we're going to write plus there. Okay, 2 more intervals to go. So the next interval here is from 0 to 4, and that's from here to here, 0 to 4. And let's go ahead and pick a number in here. I like to pick something simple, so I'm going to pick the number 1 here. Okay, 1 is in between this interval. So when I plug in 1 for x, that is a positive number. So we're going to go ahead and give this a positive sign. Plugging in 1 for x, 1 minus 4 gives me -3, and that gives me a negative sign. And then lastly, we have 1 plus 3. That gives us 4, and that is a positive number. So we're going to go ahead and put in a positive sign. Okay, and now the product is going to be positive times negative is a negative. Negative times a positive, it gives me a negative. So we're going to put a negative sign here. Okay, now we're almost done with this chart. We have one last interval to go, and that's anything greater than 4. So I'm going to pick the number 10. It's easy to work with. So if we put in 10 for x, 10 is a positive number. So we're going to give this a positive sign. 10 minus 4 is 6, and that is also positive. So we're going to give this a positive sign. And then 10 plus 3 is 13. That is also a positive number, so we're going to give this a positive sign. Okay, so then the product would be positive times positive will give us a positive. Okay, so now we're going to go ahead and graph this function. Okay, so what you will see is that in this graphing, we're not going to be concerned about how high or low the graph goes. All we want to know is what direction it goes. Okay, so what we see is that when x is less than -3, we have a negative sign, which means the graph is coming from the negative direction. Okay, so we can go ahead and graph this as such. Okay, now let's take a look at the next interval. From -3 to 0, that's from here to here, we see that it is positive. Okay, so we know that this is all in the positive territory. Okay, so we're going to graph this down here. And then from the 0 to 4 interval, they're all in the negative territory. So we're going to continue this graph as follows. Okay, and what we see is when it's greater than 4, my value is going to be in the positive direction, so we will continue this graph as such. Okay, and there's our graph. Now, what I said earlier is that we're not concerned about how high or how low this function goes along the y-axis. Okay, that's not the purpose of this particular approach. All we want to know is what direction is it coming from, where the x-intercepts are, and we use that information to graph this function. Okay, so let's move on to the next example. Okay, so here what we're going to do is try to understand how multiple zeros can affect a graph. Multiple zeros. Okay, so here's a definition for the multiplicity of a zero. So the multiplicity of a zero of a polynomial function is the number of times its related factor appears in the factor form of the polynomial. Okay, So, for example, let's take a look at these 4 different scenarios. Here we see that we have a 0 of x equal to 1 and a 0 of x equal to negative 2. Okay, so we have one occurrence here, and so what we see is a 0 at 1 and a 0 at negative 2. We see that the graph continues through the intercept and then comes back through the other intercept. Okay, now let's take a look at this second example. Here we have x minus 1 squared. So what this tells me is that an x of equal to 1 is a 0 for this function, but it's happening twice. Okay, whereas x equal to negative 2 is only happening once. So we're going to plot the x-intercept, which is going to be negative 2 here, and the other x-intercept is going to be 1. Okay, now watch what happens. When you have one occurrence, right, the function comes through the intercept, okay, and it continues through the intercept. But when we approach the other intercept, which is 1, okay, instead of going through the point like we did over here in this example, it actually bounces and goes up. Okay, so in this case it changes direction, whereas one occurrence it goes through it. Okay, it goes through the intercept. Now let's take a look at this third example. Here we have 3 occurrences of x equal to 1 and 1 occurrence of x equal to negative 2. So with one occurrence, the function goes through the intercept, okay? And as we come to the next intercept, which is 1, it actually goes through, okay? Similar to this example here. And let's take a look at the fourth example. Here we have 4 occurrences where x is equal to 1 and 1 occurrence where x is equal to negative 2. Okay, so again, with one occurrence, the function goes through the intercept. Okay, but as we go to the second intercept of a 1, instead of going through it, it actually bounces and continues up. Okay, so what can we conclude here? So when we're talking about the multiplicity of 0, okay, when the multiple is an odd number, so these are odd numbers, right? This is raised to the power of 1, this is raised to the power of 3, and the same would be the same for if it were raised to the power of 5 or 7. So when it's an odd multiplicity, the function goes through the intercept, okay, through the intercept, and then through the intercept. When it's an even number, okay, here we have raised to the 2nd, raised to the 4th, and this would be the same if it were raised to the 6th or the 8th. The function actually bounces off the intercept and then continues, okay? Bounces off the intercept and continues through. Okay, so let's go ahead and take a look at the third example, finding real and complex zeros, okay? Finding real and complex zeros. So what are the real and complex zeros of the polynomial function shown in the graph? What we're basically saying is that we're going to have real and imaginary numbers as our solution, okay? So the first thing to do is take a look at this function and determine if there's any information we can use to our benefit. And what we see is that this function actually crosses the x-axis at 2, okay? So what that means is part of our factor is going to be x minus 2 because we have the function crossing at 2, okay? So we could take that information and divide that into the function that's given here using long division. So we're going to say that this is x cubed plus x squared minus 3x minus 6. Okay, now if we were to do this division, we would see that the first value is going to be x squared, and when we multiply this out, x squared times x is going to be x cubed, and then x squared times negative 2 is going to be negative 2x squared. Okay, and this entire quantity is going to be subtracted. And when we do, we see that the final value is going to be 3x squared. And we can drop the rest of these values down. So we have negative 3x and negative 6. We're going to bring those down. Okay, now x goes into 3x squared 3x times. So that's going to be a positive 3x. And then if we multiply 3x by x, we're going to get 3x squared. And then 3x times negative 2 is going to be negative 6x. Okay, subtracting those, we'll get 3x as the result, right? 3x squared minus 3x squared is 0. Negative 3x squared minus negative 6x squared is the same as negative 3x plus, right? Two negatives gives us a positive. And so negative 3x plus 6x gives us a positive 3x. We can go ahead and bring down this negative 6. And if we divide this x into 3x, we'd see that the balance would be a positive 3. So positive 3 times x is 3x, and 3 times negative 2 is negative 6. And when we subtract those, we see that the remainder is 0. Okay, so now we know that our factors for this function f of x is equal to x minus 2, which is our divisor here, and then the balance here is going to be x squared plus 3x plus 3. Okay, so now we're going to take a look at these values here, this polynomial, and we see that we can't factor this using any technique we've learned so far. Okay, so then our last resort is to use the quadratic function, or I'm sorry, not the quadratic function, the quadratic formula, and that formula is x is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, so let me go ahead and move this equation down a little bit. And when we take a look at this function here, or this polynomial here, okay, we see that the a value here is 1. Okay, that is the coefficient in front of the x. Okay, and that's an implied 1. And then the coefficient in front of this x is 3. So we would say that my b value is 3. And then lastly, my c value is 3. Okay, so we're going to set c equal to 3. Okay, now I like to write these out because once I insert these numbers into the equation, it makes it easier for me to keep track. All right, so this then becomes negative b, which is going to be negative 3. Sorry, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And this comes out to negative 3 plus or minus the square root of 9 minus 12 divided by 2. Okay, and let's go ahead and delete this a little bit so you have a little room. That's going to equal negative 3 plus or minus the square root of negative 3 all divided by 2. Okay, here we have a square root of a negative number, in this case negative 3, and so we're going to have to replace that with an imaginary number. So that's going to equal negative 3 plus or minus the square root of 3 and then I. Okay, I is the equivalent of the square root of negative 1 all divided by 2. Okay, so what that means is x is equal to negative 3 plus square root of 3i divided by 2, and it's also equal to negative 3 minus the square root of 3i divided by 2, and it's also equal to 2. Okay, where did that 2 come? Where did this 2 come from? It is right here. We determined from this graph here that the x-intercept for this graph was minimally a 2. Okay, so that we know that x is equal to 2 when this function is 0, and we also know that when this function is 0, x is equal to this complex number, negative 3 plus square root of 3i over 2, as well as this other complex number, which is negative 3 minus the square root of 3i divided by 2. Okay, so let's take a look at one last example. So here we're going to solve this polynomial equation. We have x cubed minus 7x plus 6 is equal to x cubed plus 5x minus 2x minus 24. Okay, so what we're going to do is combine like terms, move everything to one side of the equation, and set it equal to 0. Okay, so first step is we see that we have an x cubed here and an x cubed here. When we see the same values on both sides, we can go ahead and cancel this out. Okay, all right, so we have what's left is a positive 5x squared. There's nothing along this equation that has an x squared, so we're going to leave that there. Okay, so we're going to say that this is equal to, I'm just bringing the equal sign down, 5x squared. Okay, and then I'm going to go ahead and cross that out because I've already accounted for that. And then what's left is we have a negative 7x and a negative 2x. Okay, so if I'm going to move this negative 7x to this side of the equation and combine it with negative 2x, I have to add 7x to both sides, right? So add 7x, and what we get is a positive 5x. And then lastly, we have a positive 6 and a negative 24. Okay, to move this over to this side of the equation, we have to subtract 6 from both sides. And if we subtract 6 on this side, we would get minus 30. Okay, all right, so, and this we're going to set this equal to 0 because there's nothing left on this side of the equation. Okay, so we see that 0 is equal to this polynomial. Well, I can factor out a 5 out of this polynomial because 5 is the greatest common factor. So if we take 5 out, we're left with x squared plus x minus 6. Okay, now if we divide 5 from both sides, we divide 5 on both sides, we see that the left side is still 0, and now we're left with x squared plus x minus 6. Okay, these cancel each other out because 5 divided by 5 is equal to 1. So now let's go ahead and factor this. Okay, we're going to put x's in here. So to factor this, we're going to find factors of negative 6 such that when we add them together, it comes out to a positive 1. Okay, and so we find that positive 3 times negative 2 gives me negative 6, and 3 plus negative 2 is a positive 1, and so my factors are going to be 3, positive 3, and a negative 2. Okay, now the last thing we want to do is find the zeros, right? If x is equal to negative 3, this is going to be 0, and if x is positive 2, then that's going to be 0. So this is our answer. Okay, so I apologize that this video was so long, but hopefully this made sense to you. If you were not completely clear or were confused at all, please go back to the beginning of the video and listen to this again.